Okay, so let us now calculate the mean of a negative binomial random variable. So as a recap, the PMF of a negative binomial random variable is given by this expression here, where x can take any value from 0 to infinity and all whole numbers. So let's now start with the definition of the mean. So e to the x, this is equal to x is equal to 0 to infinity x times x plus r minus 1 r minus 1 p to the r 1 minus p to the x. Okay, so now let us now play around with this expression. We have x times x plus r minus 1 r minus 1. This is equal to x times x plus r minus 1 factorial divided by x factorial r minus 1 factorial. Now what is x over x factorial? This is equal to x minus 1 factorial. Now r factorial, what I am going to do is I am going to multiply by r in the denominator and r in the numerator, and just copy the rest of the expression. So this guy is actually just r times x plus r minus 1. Choose r. Okay, now let us plug it in our expectations. So this is equal to r x plus r minus 1 r minus 1 p to the r 1 minus p to the x. Now you can appreciate that in this case x starts from 1, so x is equal to 1 to infinity. Now all the terms which do not have x we can take outside, so we can say r times p to the r times x is equal to 1 to infinity x plus r minus 1 r here and times 1 minus p x here. So actually this should be just r, so let me just erase this. Okay, now for this one let's make a change of variable. Let's use k is equal to x minus 1 and r is equal to s minus 1. So we get r times p to the r times x is equal to k is equal to 0 to infinity k plus s minus 1 s minus 1 1 minus p k plus 1. Okay, now we can bring 1 minus p outside, so we can say r times p to the r times 1 minus p times our summation now this is nothing more than the power of a geometric series. So this is equal to just 1 minus p to the negative s, which is equal to p to the negative s. which is equal to p to the negative r negative 1. So then our expected value is what? R p r 1 minus p times p minus r minus 1, which is equal to r 1 minus p over p. So this is actually the mean of the negative binomial random variable. Now let's see whether it makes sense or not. Let's say we have success probability of 0.9 and r is equal to 4. So how many tries on average do we need to get the fourth success? Now since the success probability is high, then we will expect the value to be closer to 4. Closer to 4 or closer to 0? Closer to 0 because our x starts from 0 here. So we need, if the success probability is high, then we expect very few failures before the fourth success comes. So let's calculate our expectation in that case. We get 4 times 0.1 over 0.9, okay, which is equal to 4 over 9, which is less than 0.5 actually. So this means that in order to get fourth success, we will get less than half, on average, less than half failures, okay, which makes sense. Now let's use a p value to be 0.2. In that case, our expectation will be 4 times 0.8 over 0.2, which is equal to 16. So this means that in order to get 4 successes, we will on average need 16 failures, which makes sense because our success probability is 1/5. So this means out of every 5 trials, on average 4 will be failures. So in order to get 4 successes, we need 4 times that failures. So this expression, whenever we find the expectation, is always a good idea to check whether it matches with the definition of any distribution. If it does, then more often than not, our expression is correct. So that's all for the mean of the negative binomial random variable. Very soon we will work on the variance of this random variable. Thank you for watching. Hope you like the video.